All right, so we are going to begin our second example. And this is a continuation from the previous example that I posted of how to just get p hat and q hat, the point estimates for the population proportion. So for this example, I'm going to actually finish number 5 from your practice work. So it's the same surveys, and I did correct. I noticed in my first example, I had 600 instead of 603, so I adjusted that first. But it's the same survey. 394 say they went to the dentist, 603 is the total survey. So I fixed my p hat is actually 0.65 and q hat is 0.35. So to do a 90% confidence interval, first we start by verifying that the sampling distribution of p hat can be approximately normal, and we do that by multiplying n times p hat, and we are looking to make sure this is bigger than 5. And almost always this happens with these examples, so you don't usually have to worry about it a whole lot, but you are supposed to check it to be sure. So 603 times 0.65 is about 392, which is obviously bigger than 5, so that's good. And then we check, n times q hat. So 603 times 0.35, and we get approximately 211, which is also greater than 5. And so our normal conditions are met, which means we can go ahead and do the actual work for the confidence interval. So the first thing we need to do the confidence interval, just like in 6.1, we need the critical value for z. And since we are doing the 90% confidence interval, we're going to use the critical value associated with that right here. So for 90%, it's 1.645. And so then we need to get the left and right endpoints to form the 90% confidence interval. And remember that's from taking p hat minus e for the left, and p hat plus e for the right endpoint. Okay, so we know p hat is 0.65, but we have to calculate e. So E is the same formula as before, except we had made an adjustment for it being the proportion instead of the mean. So it's our critical value for Z that has to do with the level of confidence that we want, in this case 90%, times the square root of P hat times Q hat, all underneath the square root here, divided by N. So this is all underneath the square root here. Okay, so in this case, that is 1.6, hold on. Okay, sorry, I had to give myself some more room here. So 1.645 times the square root of P hat was 0.65, Q hat was 0.35, and N is 603. So E is going to be approximately 0.03. So we are going to take P hat minus E to get our left endpoint. And P hat was 0.65 and E is about 0.03. So that's 0.62 for our left endpoint of our confidence interval. And to get the right endpoint, we're adding E to P hat. So 0.65 plus 0.03, so 0.68. So that gives us our 90% confidence interval of 0.62 to 0.68. So that is our 90% confidence interval. And what that is saying is that with 90% confidence, it can be said that the sample proportion of males ages 18 to 64 who say they've gone to the dentist in the past year, the population proportion. The population proportion is what we're saying. We have 95% confidence that the actual population proportion would be between 0.62 and 0.68, and we're 90% confident that it's in there. The last part of this example or question asks you which confidence interval is wider, the 90% or the 95%. And some of you asked me about this question on your homework from the last section. So when you think about the confidence interval, the wider it is, the more confident you are that the actual value is going to be in there. If you think about it like jumping off a building onto like a trampoline, the bigger, the wider the trampoline, the more confident you're going to be that you're going to be safe. So a 90% confidence is not as confident as a 95% confidence. So the more confident you are, the wider you need your interval to be. So a wider interval is going to be the 95% confidence interval. So these numbers will be further apart, which means you have more of a chance of catching the actual real proportion in between those numbers.